Hello, biologists. Here we are back with the Weinberg Lab and figuring out how to use our mathematical model. So I'm going to share my screen. I have two things open that pertain to you. One is the lab manual right here. I'm on page S34, I'm pretty sure is where we left off last time. And then I also have my Excel spreadsheet open. Okay, I need a second to, I should have thought of this. I think I was doing it, okay, we'll just do it right here because that way I think it'll switch back and forth the nicest. Okay, so last time we established a P and a Q, and our Q was based on our P, and we had gametes, and those gametes are the egg and the sperm, and we brought them together. That made the zygote. So next up, so I'm on this paragraph right here. The next column on the sheet, H, I, and J, are used for bookkeeping. That is keeping track of the number of each zygote's genotype. They are rather complex functions that use if functions to help us count the different genotypes of the zygotes. So instead of us having to go in and figure how many AAs do we have, how many ABs do we have, how many BBs do we have, we're going to have Excel do that for us because that is the power of spreadsheets. So in cell H5, we are going to type in the function equals if, parentheses, G5 equal, quotation marks, AA, end quotation marks, comma 1, comma 0, which basically means that if the value of the cell G5, so if G5 is equal to AA, then put a 1. And if it's not equal to AA, then put a 0. Okay, so let's type that in. So I'm going to label that number of each genotype, AA. So back to my spreadsheet, I'm going to say number of each genotype. I'm going to say right here AA, and I'm going to type in that function exactly what it is. If the letter here in G5 is equal to AA, then put in a 1, but if it's not, then put in a 0. Okay, and then I'm going to close my parenthesis and hit enter. And that one is not AA, so it gives me a 0. I'm going to hit F9 to refresh. And now it is AA, so it gives me a 1. Yay, it worked! Okay, and I can do the same thing where I click on it until it has the green outline, and then I make it so that I have the black plus and grab that little green box in the corner and drag it down to the bottom. And I should see anytime I have an AA, I will have a 1, and anytime I don't have an AA, I will have a 0. And if I hit F9, it should adjust accordingly. Fantastic. Okay, AB, and then BB. Now, AB is going to be a little bit more complicated, so let's do BB. Okay, I think that's what the lab manual has us do. Nope, yeah, there we are. Okay. So enter the following very similar function into cell J5 equals, okay, so yeah, same thing. We're going to do the same thing right here in cell J5. And then we're going to type in if this cell right here, G5, is equal to, and this time I want it to say BB, right? Because now I'm counting my BB zygotes. Then put in a 1. And if not, then put in a 0. Okay, and right now that cell G5 says BB, so says AA, so it's going to say a 0. But if I hit F9 a couple of times, hopefully one time it'll change and be a BB. Oh, there it is. And now my formula says 1, so I know it worked. So I'm going to highlight that so it's green, grab that box in the bottom right-hand corner and drag it down. And I should see that anytime I have a BB, I have a 1 in my BB column and a 0 in my AA column. Okay, so now the ABs are a little bit trickier because we have two ways we can get an AB. We can have an AB or we can have a BA. So the formula that we're going to use here is a nested, another if in there. So we're going to type in if G5 is equal to AB, make it a 1. And then if G5 equals BA, make it a 1, and if not, give it a 0. Okay, and this one often takes a couple of tries to get it right. It really needs to look exactly like this right here, except for the period at the end. You don't need that. Okay, so I'm going to go back to my Excel spreadsheet and I'm going to type in if cell G5 equals AB, put in a 1. Now let's go back and double check. What do they do? Comma. Ooh, I wasn't done. Put in a 1. Otherwise, if not, if cell G5 is equal to BA, put in a 1, but if not, put in a 0. 3 parentheses to close it all off. Okay, let's see if it worked. Okay, right now it's an AB and I have a 1. I'm gonna hit F9, I hope it worked. So AB, AA and it's a 0. BB and it's a 0. I want to say BA. I should just drag this down. Okay, let's drag this down. Okay, so green right-hand corner. Whoa, whoa, whoa. Right-hand corner right there. Okay, here is a BA and I have a 1 in the middle. Woo, it worked. Okay, so I'm gonna bold these. Actually, I'm gonna bold these, and I'm gonna put all this business in the middle because it looks nicer that way. Except for you, I don't want you in the middle. I want you to merge in center across these 3 cells. Okay. Okay, so look at that. Now I know the number I have of each genotype. And I do want to make sure this works. So do hit F9 a handful of times and make sure that it really adjusts as it should. If it doesn't, it's usually a error with the quotation marks or with the commas. So just really make sure that yours looks exactly like what it says it should in the spreadsheet. I'll show you mine here one more time. So if left parenthesis G5 equals quotation mark AA, close quotation mark, comma 1, comma 0. Okay, so that's to see if it's AA. See if it's BB, we have to make sure we have BBs instead. And then for AB, we need to do this nested function because we're counting both ABs and BAs. And then, of course, your quick little reality check, like this right here, this is an AB here in cell G10, so I know it should be a 1 for AB, which it is. This one here is an AA in cell G8, so I know it should be a 1, etc., etc. Okay, exciting use of if functions. Done well, like they can save you so much work. Like instead of going through and counting all your yeses, you can just write an if function that every time there's a yes, they count it for you. Stuff like that. It can really help. I highly recommend it. Okay, back to the lab manual. As before, try recalculating a number of times. Of course, is it what you expected? Okay, and now we can do this to have as many zygotes as we would want. So if you want more, that's fine. I'm going to keep mine at this number right for now. So I'm going to go back to my spreadsheet. And what we want to know, now that we've used this to count our number of each kind of our zygotes, is, well, to label our numbers, we want to count them. So the function that we're going to use is the sum function. I just went and added an underline to make it look nice. And I'm going to bold that. Okay, so we're going to sum up how many we have of each of these. I'm going to put a little border here at the bottom to help differentiate there with my border function again. And the function that we're going to use is sum, and sum just adds everything up. And since we have a 1 anytime it's a yes and a 0 anytime it's a no, if I just add up all the ones, I'll get the total number of yeses that I have. So I'm just going to do equals sum, left parenthesis, and I'm just go up here. It should be the little dashed line, drag it down to the bottom, and then right parenthesis. Okay, and that tells me that I had 7 AA individuals. And if I go back and double check, 1, 2, 3, 4, 5, 6, 7, yep, that's exactly what I see. I had 7 zygotes that were AA. And if I hit F9, it should change. Right now I have 9. Now I have 5. And I could retype that, or I can just drag it to the right and my function automatically updates. I had 6 AAs, 9 ABs, and 1 BB. And if I do a quick little reality check over here on the left-hand side, yep, that looks about right. Also, another reality check. I know I had 16 individuals. 6 plus 9 plus 1 equals 16. So I know I'm not missing anybody. They're all adding up to the same number. Okay. If they're not adding up to the 16 individuals or whatever number you're starting with, the error is usually in this nested function and this guy in the middle. So that'd be the one that I would go back and double check. Okay. So now our spreadsheet automatically creates random gametes, puts them together, and then counts them for us. That's so nice. Okay, so the next thing we want it to do is we want to use it to calculate our allele frequencies, okay? So they labeled here, they labeled it sums for each genotype. So, well, sounds good. I'll label mine that too. Sum for each genotype. They put in some equal, like an arrow. If that floats your boat, go for it. Seems unnecessary to me. And then they do number of each allele. Okay. So how many A alleles do we have and how many B alleles do we have? Okay. So next up, I'm going to do number for each allele. Okay. This one's going to take a little bit of math. Where they put it on there is just to make everything. Oh, they put it under the A and under the B. Awesome. Okay. So I'll do A here. And every time I change everything, okay, and I'll do B there. Okay, so I know that every AA individual has 2 A alleles, and I know every AB individual has 1 A allele, and I know every BB individual has 0 A alleles. So I'm gonna write another function to calculate the number of A alleles for me. Okay, I just put a little underline there because it makes it look nice. Okay, and so my function is going to be equals the number of AA individuals, which is my cell H21 here, times 2, because each of them have 2 A alleles, plus the number of AB individuals, because each of them has 1 A allele. Now hit enter. Okay, and quick reality check, 6 times 6 is 2, no, 6 times 2 is 12, plus 6 is 18, and that makes sense there. Okay, I'm gonna do the same with my BB individuals. So if you need to go back and look, that was H21, which was my number of AA zygotes, times 2, because each of them has 2 A alleles they're bringing to the party, and then plus my number of AB individuals, because each of them has 1 A allele. Okay, and I have to do the same for my BB individuals. This is going to be equals my total number of BB individuals. Oh, forgot my parentheses. I'm going to backspace. Equals left parenthesis. My total number of BB individuals times 2, because each of them has 2 B alleles, plus my number of AB individuals, because each of them has 1 B allele. Hit enter, and that's 9. Which makes sense because 7 plus 1 plus 1 is 9. I'm going to hit F9 a couple times, make sure it adds up. Now remember, I had 16 individuals, so I have 32 total alleles because each of them has 2 alleles. And so quick reality check, I should have 32. A plus B should equal 32. 18 plus 14, pretty sure that's 32. Seems about right. I'm going to hit F9 again. 19 plus 13, 32. Yep. Ooh, that's an easy one. 22 plus 10 equals 32. Awesome. Okay, so everything seems like it is in working order as it ought to be. Now, last part in this video, we'll make our graphs next time. The last part I'm going to do is I'm going to calculate my allele frequencies for the next generation. Okay, so allele frequencies for next, because I hate to break it to you, but this is just the beginning. We have a long ways to go. We're going to have them making lots more babies. Okay, so we're going to use this to calculate our P, and we're going to use this to calculate our Q. So I'm going to underline my P, underline my Q. Okay, so P is going to be equal to the number of alleles divided by the total number of alleles. Now, I don't want to just call that 32 because I might change the size of my population. 16 individuals is pretty darn small. So I'm going to use math, use Excel to do it for me. And that time, anytime I update anything, it will automatically adjust. Okay, so I'm going to do equals my number of A alleles divided by, left parenthesis, my number of A alleles plus my number of B alleles, okay? Because that gives me my total number of alleles. And look, it's 0.375. Cool. Now, I could calculate Q separately, or I could just do 1 minus P like we did up above. Either way is fine. I like to calculate it individually. It just makes me feel a little bit fancier. So I'm going to do equals B divided by my number of A alleles plus my number of B alleles. Okay, and these two numbers should equal up to 1 because we know P plus Q equals 1. Hardy-Weinberg said so. Okay, and 0.65 plus 0.34, that sounds about like 1. So I'm going to hit F9 a couple times. If I did everything correct, it should work. And by work, I mean everything should update every time, all the numbers should change every time, and my P and Q should equal to 1. I'm going to go up here and change my P allele at the top to 0.9. And I'm going to make sure my spreadsheet adjusts itself. I have a lot more A's, very few BB's. My P is much higher and my Q is much lower. I'm going to hit F9 and make sure it works. Looks good to me. My P is staying high, my Q is staying low. Whoa, that time it was 1. Okay, there we go. I'm going to change it back to cancel. I'm going to change this back to 0.6. And so that it is all how I want it to be for next time. Okay. They don't color them here. I'm going to go and color this P and Q because this is going to be super important for us in the next part. So I'm going to go back. I made mine yellow. So I'm going to fill these cells with yellow too. Where'd my nice yellow go? I feel like this, okay, whatever. Over to it. Okay, so I'm going to make him yellow because that will remind me that this is the P and Q my population came in with, and this is the P and Q it ended with. Okay, all right, in our next video, we will graph our data, and then we'll make more populations, and the fun will just keep going. Okay, in the meantime, just hit F9 and be really proud of yourself a couple of times. And if it doesn't work, go back, watch the part, make sure your formula is the exact same as mine. And if you're super stuck, email me or send me an email, which is what I just said. But if you include the link to your spreadsheet in it, that'll really help me be able to do some troubleshooting. Okay, and I hope you're doing well. I'm going to stop my share, and I'll see you next time.